Hello again, and welcome to Crazy Math Productions. Today we're looking at standard form of linear equation. In particular, we're looking at how it applies in a real-life scenario with a word problem. So let's go ahead and begin. Our qualities of a traditional standard form: A and B cannot both be 0. A, B, and C cannot have any common factors. So, for example, looking at number 2 here, if we had 2x plus 4y equals 6, 2, 4, and 6 have a common factor of 2, so we would have to divide by 2, and we would have 1x plus 2y equals 3, or just x plus 2y equals 3. In this case, we cannot have any common factors between A, B, and C. Okay, and A, B, and C must all be integers. Now, I'll throw in another one. This is depends on where you are on different people's opinions, but we're going to say that A is positive. We're going to try to make sure that we have the leading coefficient, which is A, to be positive. All right, now let's write these in standard form. Okay, 3y plus 2x equals -4. Now remember, standard form is ax plus by equals c. Now, we don't have the x in front, so we're going to switch these using commutative property of addition. And we have ax plus by equals c. This is correct. 2, 3, and 4, negative 4, excuse me, do not have any common factors. So 2, 3, and 4 also are integers. These are both not 0, and A is positive, so this is standard form. Number 2 here, several things going on. Number 1, we have some fractions and a decimal here. Now you get to choose. You can either make them all into fractions or all into decimals. I'm going to choose to make it into a fraction. Now you can see, I don't know if you can see that, that's a 6/10, 0.6y, 6/10 y. So we're going to go ahead, 6/10 would reduce to 3/5. So we're going to say 3/5 y equals 1/2 x minus 3/4. Now the first thing I want to do is to get rid of these fractions. If you look at 5, 2, and 4, you could multiply them all together. 5 times 2 is 10, times 4 is 40. You could multiply everything by 40, and then you would have to try to find any common terms. Or we can find the least common multiple between 5, 2, and 4. One is the box method here, 5, 2, and 4. Does anything go into at least 2 of these? Well, yes. 2 goes into both 2 and 4. So 5 will get a free round. 2 divided by 2 is 1. 4 divided by 2 is 2. Nothing goes into at least 2 of these. So we're going to multiply these. That's the LCM. 2 times 5 is 10. Times 1 is still 10. Times 2 is 20. If you're not familiar with this method, there is another. You could simply list out 5, 2, and 4, and just do some repeated addition. 5, 10, 15, 20, 2, 4, 6, 8, 10, 12, 4, 8, 12, 16, 20. Now you see 4 is not common. 6, no, 8 is common here, but not here. 10 is common, but not with the 12. 20 seems to be common here. Let's see if we could get to 2. To get to 20 from the 2, yes, we could. So 20 is the common multiple. So that gives you some different ways of finding that least common multiple. Regardless, we're going to multiply by 20. So we could rationalize the 20, make it into a fraction over 1. 20 times 3 would be 60 divided by 5, or you could simply 20 divided by 5 times 3 would be 4. Excuse me, times 3 would be 12. It's a little bit quicker version, a little bit of a shortcut. Let's try that again. 20 divided by 2 is 10, times 1 is still 10. 20 divided by 4 is 5, times 3 is 15. Now the problem is that we don't have x on the correct side, so we're going to subtract 10x from both sides. Get negative 10x plus 12y equals negative 15. And at this point, the problem is that I don't have a leading coefficient to be positive. So I'm going to multiply everything by negative 1, and I get 10x minus 12y equals positive 15. Essentially, it just changes all the signs. Okay, on this particular example, we've got 2 digits in the decimal place here, 1 digit in the decimal place here, and 1 digit in the decimal place here. So what I'm going to recommend is that we multiply everything. If you multiply by 10, you move it 1 place. Multiply by 100, 2 places. 10 to the power of 3, 1,000, moves 3 places. So what we're going to do, find the largest number of decimal places in the decimal place, a number of digits in the decimal place, which would be 2. We're going to multiply by 10 to the second power, or 100. So we're going to move this 1, 2 places, fill with a 0, so this is 40x, plus, move it twice, that is 6y, move it twice, 80. Now once we've done this, we still have to look for a common factor. So we're going to divide through by 2. Get 20x plus 3y equals 40. And at this point, we're in standard form. A, B, and C are integers. A is positive. There are no common factors between them. Okay, same thing here. We have 1 5/10, 2 75/100. We're going to multiply everything by 100 so that we can move it twice and get rid of this decimal here. And again, I have to move the decimal twice here. That gives me 150x plus 275. I have to multiply the y by 100 as well. And if you look through here, we could probably divide by 5, or you may notice that 25 would be a common term as well, so I'm going to divide everything by 25, or multiply by 1/25. You could do it either way. 100 divided by 25 is 4. 150 divided by 25 is going to be 6. 275 divided by 25. 300 divided by 25 would be 12, so this would be 11. And the only problem that we have is that x is on the wrong side of the equal sign. So we're going to subtract 6x from both sides. We get negative 6x plus 4y equals 11. We're going to multiply everything by negative 1, and we'll get 6x minus 4y equals negative 11. And that is in standard form. All right, number 5 here. We need to clear this fraction by multiplying by the least common denominator, least common multiple. Now there's only one denominator here, so we're just going to multiply it by that number, multiply by 3. So 3 times y is 3y. 3 divided by 3 is 1, times 2 is 2x, minus 3 times 2 is 6. Now again, x is on the wrong side. Subtract 2x, or you could add the opposite. We get negative 2x plus 3y equals negative 6. And again, we want the leading coefficient to be positive, so we're going to multiply everything by negative 1. So that's it. 2x minus 3y equals 6. Now for number 6, we've got 2 different things going on here. I'm going to make this 5/10 into a fraction. You have the choice. Either make them both into a fraction or both into a decimal. The problem with the 2/3 is that making 2/3 into a decimal is going to make it 0.6 repeating, and that's going to be something very difficult to work with. So in this case, I highly suggest let's change this 5/10 into 1/2. And now look for the least common multiple of 2 and 3. Well, the least common multiple of 2 and 3 is going to be 6. So let's multiply through. 6 divided by 3 is 2, times 2 is 4. 6 times 4 is 24. 6 divided by 2 is 3, times 1 is 3. So we have x on the correct side. 24 is not on the right side, so we're going to move it over. 4x equals 3y plus 24. And now y is on the wrong side, so we're going to subtract 3y from both sides. So 4x minus 3y equals 24. And there we have it. Now we're going to look at these in the context of some real-life applications, some word problems. Now, I usually go with a 5-step process. Let, write, solve, check, sentence. So we're dealing with bananas and apples. You're given $6 to buy bananas and apples. Bananas cost 40 cents per pound, 49 cents per pound, and apples cost 34 cents per pound. Write a linear equation that represents the different amounts of fruits you can buy. Well, in this case, we're going to let, I'm going to say A equal the number of pounds of apples. And I'm going to let B equal the number of pounds of bananas. There's my let. Now I want to write an equation. Now, in this case, it actually says write a linear equation. Usually there's some kind of a situation we need to solve, we need to check, make sure it's accurate, and then write a sentence about it. In this case, they only want the linear equations. We're going to get rid of these three. We do need to let the reader know what the variables represent, though. So A is number of pounds of apples, B is number of pounds of bananas. Now, bananas cost 49 cents per pound, so 49 cents per pound times the bananas. The apples cost 34 cents per pound, so 34 cents per pound times the apples. We're going to add those up. It's going to give me the total cost, which is $6. Now, this is not in standard form, but it actually didn't say to write it in standard form. It just wants a linear equation, so this will work. Do I need to write this let statement? Yes, you do. You need to let the viewer, the reader, know exactly what the variables represent in the given situation. Okay, now let's look at number 2 here. Ryan's going to buy $12 worth of fabric. He buys plain fabric for $4 a yard, plaid fabric for $6 a yard. We're going to write a linear model. So again, we're just writing the linear model. We do need to do the let statements though. So we're going to say let. So we've got plain and plaid. And they both start with P, so I guess I'll use N for plain. And that'll be the yards of plain fabric. And let D equal the yards of plaid fabric. Okay. Now they say that they have plain fabric for $4, so $4 times the plain fabric, which is M. We also have plaid fabric for $6 a yard, and that equals $12. Now, again, it just says a linear model. Just like with number 1, this would not be in standard form. We would have to multiply everything by 100 and then reduce it for it to be truly in standard form. But it just says write a linear equation. It doesn't say anything about standard form. Same thing is true here. If we wanted this in standard form, we would need to divide everything by 2 so we can get no common factors. But as it is a linear model. So we're good. Okay. Now here we're going to change it up a little bit. Not only do we have the linear model, but we're asking what are all the possible combinations. So that's going to be a little interesting. It's a little bit of a different proposition here. Okay, so paper plates, cups, plates. So let's let, let's see, P equal numbers of bags of plates. And we're going to let C equal the number of bags of cups. Okay, so P is the number of bags of plates, C is the number of bags of cups. And we're just going to put it in a traditional standard form. So bags of plates 2 times P. It's $2 for a bag of plate, and times the P for the number of bags of plates, plus the bags of cups cost $3 times the number of bags of cups, and that equals 24 is the most that we can spend. This one actually would be in standard form, except you probably would want to reverse these so that it would be in order, C then P. But as it is, it just wants a linear model. So we have done that part. Here's our linear model. And what we have not done is to try to figure out what are all the possible combinations. So let's make a little chart here. If I have 0 bags of cups, 0 bags of cups, that means that this is 0. I'm just going to plug this in, plus 3 times 0 bags of cups. Well, that means this is 0. So we end up with 2P equals 24. Divide by 2, and we get P equals 12. So if we buy no bags of cups, we get exactly 12 bags of plates. Let's try it with 1 bag of cups. So it would be 2P plus 3 times 1 equals 24. 2P plus 3 equals 24. Now we're going to subtract 3 from both sides. Get 2P equals 21 and divide by 2. Now you'll notice P equals 10.5. Now I can't buy 10.5 bags of plates, so the 1 does not work. Let's try 2. Again, this is just a little bit of trial and error here. We're plugging them in and trying to see if we can get an exact number. So let's plug in 2 bags of cups. 2P plus 6 equals 24. Subtract 6. Get 2P equals 18. Divide by 2. And P equals 9. So if I buy 2 bags of cups, I can have 9 bags of plates. Now, we just continue in this manner, but I will tell you a little bit of a hint. Because of the way that this is set up, we're going to establish a pattern here. 0 bags of cups, 12 bags of plates. 2 bags of cups. Notice we've gone up by 2. If we go up by 2 again, this one has gone down by 3. This is going to go down by 3 again. Let's just double check to make sure this makes sense. Plug in 4 for C, and plug in 6 for P. 2 times 6 is 12, plus 3 times 4 is 12. Does that equal 24? Yes, it does. So this works. So my pattern that I'm establishing here will work 0, 2, 4, 6, 12, 9, 6, 3, 0, 2, 4, 6, 8, 12, 9, 6, 3, 0. And I cannot go any further because I'm going to get a negative for my number of bags of plates, and that's just not practical. So what are all the possible combinations? They are here. I can buy 0 bags of cups, 12 bags of plates, 2 bags of cups, 9 bags of plates, and so on. We'll just put it in a tabular form there. Okay, last but not least, starting garden. We want to plant marigolds and zinnias. Marigolds cost $1.50 each, while zinnias cost $2.50. Let's go ahead and put our let statement. Going to let M equal the number of marigold plants. we're going to let z equal the number of zinnias. And we're going to go ahead and write our linear model. So the marigolds are 150. The zinnias are 250. That equals $15. You might also notice that we could write it this way: 1 5/10 m plus 2 5/10 z equals 15. In fact, that's probably preferred. And here's the question: how many zinnia plants can you buy if you have 5 marigold plants? Notice in the last question, they asked what are all the possible combinations. Well, we had to list all of them. Here, it's being very specific. How many zinnias? Well, 5 marigolds, we're going to plug in 5 for m. So 1 5/10 times 5 marigolds. And we're going to solve and try to figure out how many zinnias we can get. Well, 1 5/10 times 5, 7 5/10. We're going to subtract that from both sides. Get 2 5/10 z equals 7 5/10. Now we're going to divide both sides by 2 5/10. And z equals 3. And we do need to answer the question, how many zinnia plants can we buy if we buy 5 marigold plants? And I'm going to say we can buy 3. We can buy 3 zinnia plants. So when you're looking at these word problems, it's very important to answer their question. They didn't want to know all the possible combinations. They just wanted to know how many zinnia plants. And in this one, again, they weren't looking for a specific one. They looked for all the possible combinations. Now, in these two, they weren't asking for anything more than the linear equation. And they didn't specify that it had to be in standard form, so you could leave them with a decimal here, with a common factor there. Thank you so much, and have a good day. Thank you so much for listening to Crazy Math Productions.